Implicit differentiation can be one of the more tough topics in calculus, but maybe you got that down, you're feeling pretty good about how to find dy dx, but then all of a sudden you get a curveball and the problem tells you to find dx dt. What the heck does that mean? Well, I'm going to show you exactly how to deal with that in this video with an example problem where we're going to be finding dx dt based on a given equation. So if that's a notation or something that the problem's asking you to find that's really throwing you off and you're not quite sure how to start, or maybe you're stuck somewhere along the way, be sure to stick around to the end of this video and I'll help you straighten that out so you can get to the answer. We're going to be going through a specific example, which this video is actually coming from my weekly live stream that I did last week, and that I do every Monday night at 5 o'clock Pacific time. So if you do get some value out of this video, be sure to hit that subscribe button while you're here so you're notified when I'm going live each week and you can come get questions answered live. Anyway, let's go ahead and jump into the problem and I'll show you how to find dx dt so you can get that problem you're stuck on done and move on to the next one. Let's jump on into it. Okay, so we're going to go ahead and find this by implicit differentiation. So we have this equation which relates x's and t's. First thing we want to do is figure out which of these letters we want to treat as our variable and which one we want to treat as a function. So since we have x on top, we're finding dx dt and dt on the bottom. That right there tells you x is your function and t is your variable. Okay, so we're going to treat t as the variable, x as the function. As a result, what we need to do is take the derivative of both sides of our equation with respect to our variable. So we're going to take the derivative of both sides of our equation with respect to t. So we're going to take d dt of this whole equation, both sides of it. So taking the derivative of the left side of our equation with respect to t, remember we need to treat t as a variable, x as a function. Well, we have a fraction here, so we're going to use quotient rule. Quotient rule says that what we need to do is we need to first determine our top and our bottom. So f is going to be your top function. G is going to be our bottom function. So f is x, g is t. Then you want to find f prime and g prime. The derivative of f, or the derivative of x with respect to t. So keep in mind here, t is our variable. We're taking the derivative of x, which is a function of t, with respect to t. So since x is a function, an unknown function of t, the derivative of x is not just going to be 1. That would be the case if we were taking the derivative with respect to x. But since we're taking the derivative with respect to t, we need to treat x as a function. If x is an unknown function of t and we take the derivative with respect to t, the derivative of x is just going to be the derivative of x with respect to t. dx dt literally just means the derivative of x with respect to t. We don't know x, so we can't know x's derivative either, but we can say the derivative is dx dt. Then we need to take the derivative of g, which is t. The derivative of t with respect to t is just 1. Okay. Now quotient rule says we're going to do low d high, so low times the derivative of high, the derivative of the top, so t times dx dt. Low d high minus high d low, so minus f times g prime, so x times 1 is just x, and then that's going to be all over the bottom squared. Our original bottom function is t squared is going to be our denominator. Okay, so that is the left side of our equation. Now for the right side of our equation, we need to take the derivative of x. Well, the derivative of x is, again, we need to take the derivative of x with respect to t. T is our variable, x is a function. Just like we said here, the derivative of x with respect to t is dx dt. So x is going to become dx dt. And then plus the derivative of cosine of t. The derivative of cosine of t would actually be minus sine of t. So instead of plus, I'm going to write minus sine of t. Because t is our variable, this term right here only contains our variable that we're taking the derivative with respect to. So that's going to behave as expected. The derivative of cosine is minus sine of your variable t. Okay, so this is the end of the differentiation step. Okay, so now that we've taken the derivative of both sides of our equation, what we need to do is move all of our dy dx terms to one side of the equation, move all of our non-dy dx terms to the other side. However, in this case, it's a little bit of an added step, kind of like a pre-step to that, because having this fraction here kind of makes that difficult. So what we actually want to do first is basically get rid of the fraction by multiplying that over to the other side of the equation so that we have everything all on one line, like no fractions basically, other than the dx dt, of course. So that's going to cancel with that. We're going to be left with t times dx dt minus x equals, and then what I'm going to do is go ahead and distribute this in. So we do want to do that as well. So basically, kind of a part of this moving all the dy dx terms or dx dt terms to one side of the equation and the non-dx dt terms to the other side, you kind of want to think ahead to that. What you kind of want to do first is typically expand your whole equation out. Get rid of all your parentheses, distribute those out, get rid of your fractions, multiply the denominator over to the other side. Just get everything expanded out as much as possible, because that is going to put us in a situation where we can add or subtract the dx dt terms over to one side of the equation and the non-dx dt terms to the other side. So t squared times dx dt is going to be t squared dx dt, and then minus t squared times sine of t. Okay, so now this is fully expanded out. There's no more real simplifying we can do here to, or maybe that's not simplifying. Simplifying would be like factoring out and stuff. We want to do the opposite. We want to get it fully expanded out so that now what we can do is we can just simply subtract all of our dx dt terms over to one side of the equation and vice versa. So actually, this is kind of an interesting problem, because what we're about to do, typically what we would want to do at this point is minus all of our dt terms to one side. So we would minus t dx dt in order to move it over to the left side of the equation. But you see what that's going to do here is it's going to cancel that out fully from both sides. And it's going to leave us with minus x equals minus t squared times sine of t, which we would not really expect. So this is a very odd problem, if I didn't make any mistakes, which I'm wondering if I may have done. So it is right here. When I distributed this into this term right here, I wrote t times dx dt. That is not correct. It should be a t squared. All right. Sorry about that. That is more like what I was expecting to see there. So let's carry on from there. So we get that t squared times dx dt, and then t squared times negative sine of t leaves us with this. Okay. So now what we need to do, like I was saying before, let's circle back to that. We need to subtract or add all of our dx dt terms to one side of the equation and our non-dx dt terms to the other side. So first thing I like to do is just kind of circle, where are my dx dt terms, where are my non-dx dt terms. So you can see in blue here, we have dx dt here, and then in red I put this minus x and this minus t squared times sine of t do not have a dx dt. So basically we want to move our dx dt term over to the left and our non-dx dt term over to the right. So to do that, basically we are just going to minus this t squared dx dt from both sides, minus t squared dx dt from both sides, and then we're going to add x over, plus x plus x. We're going to do that to both sides. That's going to cancel that there, and then it's going to cancel that there. So we're going to be left with, on the left side, t times dx dt minus t squared times dx dt equals negative t squared times sine of t plus x. Okay. So then once we have gotten all of our dx dt terms to one side of the equation, so you can see every term over here on the left side now contains a dx dt, and every term on the right does not contain a dx dt. So once we've kind of separated those out, what we can do, since every term on the left side of our equation has a dx dt in common, we can factor that out of the left side of our equation. So we'll pull dx dt out of the left side. And what's that going to leave us with? If we take a dx dt from this term, we're going to just be left with a t. If we take dx dt out from this term, we're going to be left with minus t squared. Okay? We did not do anything to the right side of our equation. All we did was factor out something from the left. So this is going to remain unchanged. And then now we've gotten this equation to a point where we only have a single dx dt term, which is great because from there to get dx dt all by itself, which remember the problem said find dx dt, that's what we were originally told to do. What we're trying to do is solve for that dx dt, which now we only have one of. So to get it all by itself, all we have to do is divide all this stuff right here that dx dt is being multiplied by. So divide by t minus t squared, divide by t minus t squared. That's going to cancel the t minus t squared on the left, leaving us with dx dt equals everything over here. And that's it. Hey, thanks for sticking around to the end of the video. I'm guessing you found this video helpful if you stuck around so long. If so, do me a huge favor and go hit that thumbs up button down there, right down there. And that subscribe button too while you're down there. Because if you found this video helpful, I'm sure you're going to find my other videos helpful too. And if you hit that subscribe button, you'll be notified when I come out with my new videos each time. And if you keep coming back and watching them, I'm guessing we'll keep crushing it all term long in calculus. So just go hit that button down there. And if you do want to keep learning about implicit differentiation, I have made lots of other videos on the topic. Just go click on one of those videos over there, and I'll see you next time.